Good afternoon, everyone. Am I audible? Okay. So here it is National Program on Technology Enhanced Learning NPTEL, and this is your problem solving session on recent advances in transmission insulators. And I'm your teaching assistant, Nida Khanam from Department of Electrical Engineering, Aligarh Muslim University. Okay, so today we will discuss some precaps of the topics we have already covered in previous sessions. After that, we will solve some objective comprehensive questions which are based on all the topics covered in previous sessions. Okay, so first of all, uh, one second. Okay, so basically we studied in this subject like how many types of insulators, what are the insulators, and how transmission technology is developed, what are the different standard transmission voltages which are used for in which are used in India as per IS standard, and what are the line to line voltages adopted, and different things. Okay, so basically transmission insulators are specialized components in power systems that support conductors and provide electrical isolation, as you all know that. But the main role of transmission it's in transmission systems are it basically provides the mechanical supports and also electrical isolations, and it gives the environmental protection, like it can register factors like wind, rain, pollution, and extreme temperatures to maintain operational stability. Okay, so basically in 1977, when the transmission technology is developed, it was 220 kilovolt. But as the time passes, it reaches to world's longest multi-terminal HVDC like 800 kilovolt in 2012. Okay, so in 2017 to 18, it reaches to world's highest voltage level, and test station charged in October 12. Okay, so there are some. Sorry. Okay. So there are some standard transmission voltages which you have to learn for exam. Like if there are some nominal system voltages 132 kilovolt, 220 kilovolt, 400 kilovolt, or 765 or 1150, then the question 1150, then question will be asked, will what is the maximum operating voltage for suppose 765 nominal kilovolt voltage? Then our answer would be 800 kilovolt. Okay, so this table is very important for exam purpose. So you have to learn this line to line voltages, and what would be the maximum operating voltage, and beyond that maximum operating voltage there will be no case because insulation failures occur. Okay, so this is the power intensity at different voltage levels. Suppose if we see the voltage level plus minus 800 kilovolt, then maybe question would be asked like what would be the right of way in meters for 800 kilovolt approximate voltage. Then answer would be 70 meters. Okay. Similarly, when 70 to 80 megawatt capacities, the voltage level is defined as 132 kilovolt, and right of way in meters is 27 meters, and the maximum power intensity at 132 kilovolt voltage is 3 megawatt per meter. Okay, so this table is also very important for exam point of view. You will have to learn it. Okay, for you will be asked for different voltages level what would be the ROW, right of way, or you will be asked what will be the maximum capacity or what would be the maximum power intensity at a different voltage level. Okay, now next we see the insulation coordination. The insulation coordination is a process of designing and selecting insulation levels. Okay, so why we are providing insulation coordination? Because we want a safe and reliable operation of electrical systems. So by doing this, we can protect the equipments from over voltages and which can caused by lightning, switching surges, or any types of faults. So basically it provides a safe operation, optimized design, and environmental adaptation. Like it can address challenges like pollution, humidity, and temperature variations. So I am going through some only brief introduction on which I have discussed earlier. After that, we will discuss some objective questions, which are a comprehensive objective questions based on all the topics covered since last sessions. Okay. So this is also very important table. Like you will be asked like what are the voltage level for factors which are responsible for insulation design. So voltage level for 0 to 4 kilovolt. So main factors depends on mechanical clearance. Okay. Similarly, for 4 to 34.5 kilovolt voltage levels, the main factors it depends on corona and surges. Similarly, for 69 to 220 kilovolt, the main factors lightning and switching surges, which is responsible for insulation design. So these are the factors which are responsible for insulation design for specific voltage. So for EHV and UHV, that is extra high voltage and ultra high voltage, pollution and contamination performance is very important. Okay, now there are some standards which are already set. That is some international standards like IEC 60071, that is 60071. It is the principles of insulation coordinations, and second standard is IEEE standard 1313.2. This standard is used for guide for high voltage insulation coordinations. Okay, so these twin standards are very important for defining the insulation coordination and high voltage insulation coordination guide. This is next is simulation and testing tools. So for simulation purpose, we use the EMTP. EMTP is the electromagnetic transients program for over voltage analysis and high voltage testing laboratories for insulation performance evaluations. Now, so basically there are three types of insulators, like ceramic insulators, glass insulators, and polymer insulators. Polymer insulators also known as non-ceramic insulators. Okay, so this is the structure of ceramic insulators, in which we see the malleable iron cap, malleable or ductile. So this is the Portland cement, after that bituminous coating, sandband. This is the porcelain shell. Okay, so here also malleable or forged iron pin is attached here, and this is the iron cap. This is the structure of ceramic insulators, which are used as traditional insulators, which are used earlier when the transmission insulators comes to the picture. Okay, next is the glass insulators. How it looks like, so you can see in the diagram, like glass insulators are made up of glass, and it's a very brittle in nature and very delicate. And now third is polymer insulators. This is the diagram of structure of polymer insulators, in which we see that end fittings at tower end and at energized end. Okay, so there are also fiber orientations, rubber housing, and GRP composite rod. Okay, this is the inside structure, but how it actually looks like, this is the clear picture. Okay, so this is the hybrid, this is the polymer insulators. So these three types of insulators, there is a comparative analysis, comparison of non-ceramic, ceramic, and glass insulators, in which there are some features. Based on that features, we classify them. Like I have already discussed it, but if we see the non-ceramic insulators, its installation is very easy, but as compared to ceramic and glass insulators, but its cost is very higher. Okay, so the it is very lightweight, but ceramic and glass insulators are very heavy. So you can go through this table also, and uh, remember this. Okay. So here we see the advantages and disadvantages of all the three types of insulators. And if we see that porcelain insulators, it is having high mechanical strength, excellent resistance to UV and aging. And but the main disadvantage of porcelain insulators is it's very heavy and prone to cracking under if mechanical stresses is very high. And for glass insulators, it's higher dielectric strength, self-healing properties for surface defects, but it's very fragile and limited resistance to vandalism. Okay. Now, third is polymer insulators, which is very light in weight and resistant to pollution and vandalism, and it's very flexible design options. But the main disadvantage of polymer insulators is it is susceptible to aging under UV and weathering, and it's less prone long-term performance. Okay, these are the comparative analysis of all the three types of insulators. So now we see the reliability of transmission insulators. So transmission insulators are a very essential component in high voltage and extra high voltage power transmission system. So main function of transmission insulators are used to provide the are to provide the electrical insulation where between the live conductors and grounded structures. So while withstanding environmental and mechanical stress. So reliability is very important phenomena for transmission insulators because it maintains the stability and efficiency of power grid. If insulator failures occur, then it can lead to power outages, equipment damage, and safety hazards. So for this, we check the insulators for reliable operation, and to ensure the reliable operation, insulators undergo rigorous design, material selection, extensive testing, different types of testing, and before being deployed into power systems. So there are some factors which affects the reliability, like we see the electrical stresses are due to the over voltages which can lead to flashover, mechanical stresses, environmental stresses, and aging and degradation because after use of insulators long time, it gets weakened. Okay, so over time, due to continued exposure to harsh conditions, so insulation properties are decaying day by day. Okay. Now after reliability, we see the different types of testing for high voltage testing of transmission insulators. As we know that transmission insulators are subjected to various electrical, mechanical, and environmental stresses. So there are some high voltage testings which are based on some standards like IEC 60383, IEC 61109, and NCC 29 and IS 731. So these standards are basically used for high voltage testings, which are set by Indian standards. And this test ensures that insulators can withstand electrical stresses without flashover or breakdown. And it can have sufficient mechanical strength to support conductor loads. And it can also register environmental factors like pollution, UV radiation, and temperature changes. Okay, that's why we do the testing of transmission insulators. So we have already discussed the types of testings, different types of testings that the insulator should have to pass the test. Like there are four main categories like type test, routine test, acceptance test, and special test. So type test, it is conducted on prototype samples to validate performance, also known as design verification test. Second is a routine test, also known as quality control test. It is performed on every insulators during production. Okay. Third test is acceptance test, which is also known as batch sampling test. It is conducted on a batch of insulators before deployment. Now, fourth is a special test. This is used for long-term performance and environmental test, and it is used to simulate the real-world conditions. So these are the testings which have been done for the insulators. So now after testing, there are some failure prevention strategies, like we have to select the design criteria, like we have to use some high quality raw materials for all the three types of insulators, and we have to apply the UV resistant and hydrophobic coatings, and after that testing and quality control, and we ensure the proper installation and maintenance for electrical insulators to prevent stress concentrations and to detect the insulation degradation early. Okay, so now for there are some selection of cleaning methods which are based on environmental conditions. So for environmental conditions, dry and dusty areas, the recommended cleaning method is brushing, air blowing, and for dry coastal regions or salt deposited region, we recommend the company recommended the high pressure water jet hydrophobic coatings, and for industrial areas we see the chemical cleaning, steam cleaning, and for desert environments we see the air blowing or silicone coatings are done. Okay, similarly, this table is also very important for environmental conditions and recommended cleaning methods, which cleaning method will we have to apply for different type of environmental conditions. So now we see the coating methods. Coating methods are done for the insulators to provide, if insulators are highly polluted areas, then the best coating type we should provide the RTV silicon or fluoropolymer coating. Okay, these coatings are already discussed in very detail in previous session, uh, in week 3 or in week 3 session, I think. So in for the factor coastal and salty environments, we see the hydrophobic silicon or graphene coatings, and for industrial pollution resistance, we the best coating type is zinc coating, ceramic glazing, and two for ease of applications, simply we apply the spray silicon and brush on RTV. Okay. So the now last topic was hybrid insulators. So hybrid insulators basically the combination of polymeric insulators and ceramic or glass insulators. So this is the structure of hybrid insulators where we see the uh, main components, that is core, shed material, and fittings, porcelain or glass housing. So here we see the porcelain core, silicon shades, metal fittings. So core, it is made up of fiber reinforced polymer, like also known as FRP, for providing the high tensile strength. And shed material is silicon rubber or polymeric materials that provide the hydrophobicity and pollution resistance. And third is end fittings. End fittings is made up of metal and metallic components for providing the mechanical support and connection to the power lines. So last is the porcelain or glass housing. Here we can see porcelain core. uh, it provides the additional mechanical strength and protection against environmental factors. So this is the hybrid insulators which are nowadays has been used widely. uh, Okay, now based these are the overview of the topics which I have selected, only important topics from the previous sessions, and you can go through in detail in previous classes, which is uploaded on YouTube. Okay, so based on this, will see we will see some objective questions, comprehensive objective questions based on all these. So, are you ready for objective questions? Then I will start. Okay. Okay, now. So basically, what is the primary function? First objective question is, what is the primary function of transmission line insulators? Options are conduct electricity. Option B is support and insulate conductors. Option C is regulate voltage. Option D is protect against overcurrent.
B.
B. All of you have to give answer. Amal Santosh.
B.
B.
B,
Okay.
madam.
Okay. Okay. So the correct option is B, and that main function of transmission line insulators is used to support and insulate conductors. Now the next question is, which material is most commonly used for manufacturing overhead transmission line insulators? Options are mica, glass, PVC, and porcelain.
Glass, madam.
Anyone else?
Porcelain.
Hmm?
Porcelain.
Porcelain. Amal Santosh.
Yes.
Which option? Glass.
D. D. D.
Porcelain. Okay. So glass is not the correct answer. Porcelain is right answer. This is the most commonly used for manufacturing overhead transmission line insulators. Okay. So the next question is, what is the typical voltage rating of standard disc insulators used in suspension type insulators?
It's 11 kV, madam.
Okay. Anyone else?
11 kV.
Okay, 11 kV is the right answer, and each disc is made up of 11 kilovolt for suspension type insulators. Okay, you will have to find out the efficiency if number of discs are given. Okay, and voltages across the number of discs are given and voltages across each disc are given. Then you will, if the question is find the efficiency, then you can find out. Okay. Uh, how is the string efficiency of a suspension insulator defined? Options are given here. Flashover voltage of 1 unit upon number of units into flashover voltage ratings. B option is flashover voltage of string divided by number of units into flashover voltage of 1 unit. C option is number of units into flashover voltage of 1 unit divided by flashover voltage rating voltage of strings. Option D is flashover voltage of string divided by flashover voltage of 1 unit. What would be the answer? Anyone?
B, madam.
Okay.
Flashover voltage of string divided by number of units into flashover voltage of each unit.
Okay. From this formula, we can find out the string efficiency of suspension insulators. Okay. Option B is correct. Now the third question is, which type of insulators is typically used for 132 kilovolt transmission lines?
32
Option.
kV, that is suspension type, madam.
Okay.
A. Pin type.
Okay. Anyone else? Suspension, and second option is pin. Anyone else? Okay. Okay.
Pin
No.
insulator is up to is 11 kV and 33 kV pin insulators. And
Mhm.
shackle inserts are up to 33 kV. I think so. Suspension is the right answer. I think so.
Yeah, suspension type insulator is correct answer for 132 kilovolt transmission lines. Okay. Now the next question is, what is the primary advantage of using suspension insulators over pin insulators in high voltage transmission lines? Options are lower cost, better mechanical strength, easier installation, higher electrical resistance.
Better mechanical strength, I think so. Sorry, mechanical strength, better mechanical strength.
Okay, Dilkesh and Amal, you can also give the answer.
B. Better mechanical strength.
Okay, so the correct option is suspension type insulators provides the better mechanical strengths. Okay, as compared to pin type insulators. Option B is the correct answer. Now, in a suspension insulator strings, which disc experiences the highest voltage stress? Options are top disk, middle disk, bottom disk, second from the bottom disk.
Top disk, madam, near to the line.
Okay, anyone else?
Top disk.
Okay, top disk is the correct answer. Option A is correct. Okay. Now the next question is, what is the purpose of using a mechanical safety factor in the design of suspension insulator strings? Options are to account for manufacturing defects. Option B is to provide a margin for mechanical stresses. Option C is to ensure uniform voltage distribution. Option D is to reduce electrical losses.
Profit margin for mechanical stress, madam.
Okay,
B,
anyone
ma'am.
else? B? Okay, so the main advantage of suspension type insulators is that it is used to provide a margin for mechanical stresses. It is very important for it's in the main property of suspension type insulator is its mechanical strength is very high as compared to pin type insulators or any other. So next question is, which of the following material is not commonly used for high voltage transmission insulators?
Wood, madam.
D, wood.
Okay, D is correct answer. Now next question is, what is the primary disadvantage of using glass insulators compared to porcelain insulators? Options are higher cost, susceptibility to vandalism, C is lower dielectric strength, D is difficulty in manufacturing complex shapes.
I think my options are either B or D, madam. Maybe I think maximum 90% is susceptible to vandalism.
Mm, B or D?
D.
Okay, Dilkesh.
B, ma'am.
B. Yeah, B is the correct answer. It is susceptible. The answer is susceptibility to vandalism is the primary disadvantage of using glass insulators as compared to porcelain. Okay, next question is, which type of insulators is commonly used at the dead end of low voltage distribution lines? Options are hmm,
Shackle type, madam.
shackle type. Okay, and voltage range.
About 11 kV, madam.
Okay,
Or
yes.
415.
Hmm. The option B is correct. Shackle type insulators are used at the dead end of the string, low voltage distribution lines. Now, the next question is, what is the effect of contamination on the performance of transmission line insulators? Options are increase mechanical strength, B is reduce electrical resistance, option C is enhances voltage withstand capability, and option D is it can lead to leakage currents and flashovers.
It could lead to leakage currents and flashovers, madam.
Okay, anyone else? Option.
A, increase mechanical strength.
Can lead to leakage currents and flashovers.
Yeah, option D is correct. The main effect of contamination is it can lead to leakage currents and flashovers. Okay. Mechanical strength, how it will increase by contamination? It's wrong. Okay. It can lead to leakage currents and flashover due to the contamination or pollution. Now the 13th question is, how does the number of discs in suspension insulators string affect its voltage ratings? Options are increases linearly, option B is decreases linearly, option C is increases logarithmically, option D is does not affect the voltage rating.
Maybe A or C, madam.
No.
Increases linearly or increases logarithmically.
How?
I think if the voltage is increasing, number of discs also increases, madam. So
Hmm.
does it not affect the voltage rating?
Hmm. Which
So
option?
uh, it is C.
C.
C logarithm.
Anyone else? Actually, it does not affect the voltage rating
Okay, madam. But
because
for the example, if you take 11 kV, we are using one disc, madam. For 33, we are using three discs. This increasing the voltage, the number of discs also increasing,
hmm.
but not affecting the voltage rating. You not can't understand the answer.
Okay.
Please explain it, madam.
Number of disc in suspension string. I think string efficiency affects due to the if we increase the number of disc or voltage rating affected by the string efficiency. But you are also right. Yeah, I am confused actually. I you were saying increasing log. Yes, C option. Okay.
Log. Yes, madam. It's verified, madam.
Thing. It should be increases linearly. I think. Hmm?
Maybe I think that's why A or C, madam. That's why I confused.
Yeah, yeah. Option
Because
A is correct. Because you are right, if we use the voltage rating is 132 kilovolt, then 132
yes,
divided by 11 is 11, no? 11
even
discs
but
are required.
we
Okay.
are using nine discs, madam, for
Yeah,
132 kV because string efficiency also calculated. That's why number of voltages increasing, number of discs also
also
decreases.
increasing. Hmm.
Yes,
Okay, so the correct option is A, that is it increases linearly. Okay, now the next question is what is the primary cause of voltage distributions unevenness across disk in a suspension insulator string? Options are differences in disk material, presence of shunt capacitance, manufacturing defects, and varying mechanical tension.
it is presence of shunt capacitance, madam.
Okay, anyone else?
D.
Presence of shunt capacitance in cross arm. Okay.
Yes.
15th question is which type of insulation? Option B is correct for main reason of uneven voltage ratings of suspension type insulators. Question number 15th is which type of insulator is used to insulate stay wires from poles?
It is stay
D.
insulator, madam. Stay or against insulator, above insulator, sir.
Stay insulator options. Which option?
D.
And D, madam. D. Stay insulator, above insulator, against insulator, whatever.
Yes, yes. Okay, good. Now, what is the typical dielectric strength range of porcelain used for insulators?
Uh, 25 to 30 kV, madam.
Anyone else? Yeah, typical range is 25 to 30 kilovolt per millimeter. It is the dielectric strength range of porcelain used for insulators. Okay, option D is correct. Now, the next question is which of the following is a key consideration in the design of UHV, that is ultra high voltage transmission insulators? Options are minimizing mechanical strength, maximizing surface area. Option C is controlling leakage currents, and D is reducing the number of discs.
Controlling the leakage currents, madam.
Okay, anyone else? Op- which options? Select, please.
C, madam. C.
Okay, option C, that is controlling leakage currents. It is the key considerations in the design of UHV transmission insulators. Option C is correct. Now the next question is, what is the primary function of stay insulator in a transmission line? Options are support the transmission tower. B is insulate stay wires from the tower. Option C is connect conductors to the tower. And D is provide electrical grounding.
That is answer B.
B is the correct answer. Insulate stay wires from the tower.
Tower.
Okay, now the next question is, which of the following factors does not significantly affect the performance of transmission line insulators? Options are ambient temperature, wind speed, solar radiation, moon phase.
Hmm.
Hmm?
Moon phase में ना
moon phase.
Yeah, D is the correct answer. It does not significantly affect the performance on insulators. So remaining three are affected are used for the are affected the performance of transmission line insulators like ambient temperature, wind speed, and solar radiation. But moon phase is the correct answer. So now next question is, what is the typical mechanical strength requirement for suspension insulators used in high voltage transmission lines? Options are to withstand conductor load and wind load. Option B is to support the weight of the transmission tower. Option C is to resist corrosion from environmental factors. And D is to handle thermal expansion of conductors.
Option is A, madam. Withstand conductor load and wind load.
Option
A.
A, to withstand conductor load, wind load. Anyone else? Okay, the correct answer is to withstand conductor load and wind load. Okay, next question is, which type of insulator is most suitable for use in areas with high pollution levels? Options are porcelain insulators, glass insulators, polymer composite insulators, D is ceramic insulators.
Answer is glass insulator, madam.
Glass insulator.
Yes, I think so. Either ceramic. Glass insulators or ceramic.
C, ma'am.
Polymer composite insulators are most suitable for use in highly pollution
Icon.
level
Levels.
areas. Okay, option C is correct. Now the next question is, what is the main advantage of using polymer composite insulators over traditional porcelain insulators? Options are better performance under polluted conditions, lower cost, higher dielectric strength, and easier to manufacture.
I think A, madam, better performance under polluted conditions.
Yes. Because we use polymer composite insulators in highly polluted areas, so it provides a better performance as compared to traditional porcelain insulators. So what is the next question is, what is the disadvantage of polymer insulators when compared to porcelain insulators? Options are higher weight, lower mechanical strength, susceptibility to UV degradation, and reduced cost efficiency.
B or C, madam. Options B or C.
C,
Okay.
ma'am.
Yes, so option C is correct. Susceptibility to UV degradation is the disadvantage of polymer insulators. Okay. Now the next question is, what material is commonly used in modern composite insulators for high voltage transmission lines? Okay, options are
Fiberglass.
options are mica, fiberglass, lead, aluminium.
Fiberglass.
Yes, fiberglass is the correct answer, which is commonly used in modern composite insulators for high voltage transmission lines. Now the next question is, which of the following is a common method used to clean polluted insulators? Options are chemical cleaning, physical brushing, water spraying, dry cleaning.
B. Physical brushing.
Anyone else?
Chemical cleaning, madam.
Water spraying can be the answer. Is water spraying is
Maybe by helicopter method also there is water spraying, madam. That method is also same.
okay, because water spraying is the most common methods to use to clean the polluted insulators. Okay. The next question is, what type of insulators is used in junction of the overhead and underground transmission system, transmission lines? Options are suspension type, transition type, pin type, shackle type.
I think shackle type, madam, because they are used at junctions with turning points. They will good for mechanical strength and they will take mechanical strength. Means the turnings is there. Yes, it will be avoiding bending of inserts or breaking of inserts. That way, shackle inserts are better to use it junctions or turns.
Shackle type insulators where we use at the end of the turning point, you are
Line
saying.
turning points are end lines. Taking mechanical strength, that means uh, mechanical stress of the conductors.
Okay, but this is the question, what type of insulators is used in the junction of overhead and underground transmission lines?
B. Ma'am.
Junction.
Option B is the right answer, transition type. Okay. Okay. B is the correct answer. And next question is, which of the following factors influences the flashover voltage of insulators? Options are
Option B, madam, the pollution level on the insulator surface.
okay, pollution level on the insulator surface. Anyone else? Okay, the main factor, that is the pollution level on the insulator surface, which influences the flashover voltage of insulators. Now the next question is, which type of transmission insulators is most affected by moisture?
Sure.
Most affected by moisture.
Polymer insulator, madam.
Polymer insulators. Anyone else? Is there any chances of glass insulators? No?
No idea, madam.
Hmm?
No idea about that.
Okay. Polymer insulators is the correct answer, which is most affected by the moisture. Okay. Option B is correct. Next question is, what is the purpose of using anti-pollution coating on insulators? Options are
B, madam, answer B. Reduce leakage current and improve performance of polluted conditions.
okay.
Yes, ma'am. B.
B. Okay, option B is correct. It is used to reduce the leakage current and improve the performance under polluted conditions. That's why we use the anti-pollution coatings. Okay, next question is, what is the primary benefit of using glass insulators in transmission systems? Options are low cost, high dielectric strength, high mechanical strength, easy installation.
High dielectric strength or low cost, madam? A or B?
A or
Mechanical
B?
strength is A or B?
High dielectric strength
Yes, madam.
or mechanical strength?
B, madam.
B, ma'am.
High dielectric strength.
It's the primary benefit of using glass insulator is it is used to provide the it provides the high mechanical strength.
Okay.
Okay, option C is correct. It's the main advantage of glass insulators over pin type or pin type insulators, like it provides the high mechanical strength.
Okay.
Now the next question is, which of the following is an advantage of composite insulators over porcelain insulators? Options are higher cost, easier to handle and install, better resistance to vandalism, and higher flashover voltage.
Answer C or D. Better resistance to vandalism, madam.
Okay. Okay, the polymer insulators. The main advantage of polymer insulator is lightweight, resistant to pollution and vandalism. Okay, but for glass insulators, the disadvantage is limited resistance to vandalism. Okay, the mm, option C is correct. The composite
Better
insulators provide better resistance to vandalism. Okay,
vandalism. Okay.
C option is correct. Now the next question is, in which type of environment are ceramic insulators generally preferred over polymer insulators? Options are coastal regions, dry regions, areas with high pollutions, and high altitude regions.
Ceramic for dry regions, madam.
Anyone else? So the correct
B,
answer,
ma'am.
it's option B, dry regions. In dry regions, ceramic insulators are preferred over polymer insulators. Okay, B option is correct. Now the next question is, what is the most critical parameter for ensuring the safe operation of transmission line insulators? Options are material used, second is surface condition and cleanliness, option C is voltage rating, and D is number of discs used.
Option B or C? Or C, madam. I think in option voltage rating is, I think,
Option B or C?
B or C.
Okay, anyone else? Dilkesh, Amal, Santosh?
B, ma'am.
B?
B.
Correct option is B, that is surface condition and cleanliness. Okay. The next question is, which component of a transmission system is responsible for reducing the stress in an insulator or string? Okay. Options are strain insulator, suspension insulator, conductor, transformer.
Strain insulator, madam.
A.
Yes, A is the correct answer. Strain insulators. Question number 35 is, what is the typical service life of a well-maintained transmission line insulators? Options are 5 to 10 years, 10 to 15, 25 to 40 or 50 plus years?
10 to 15 years, madam.
Okay, anyone else? Okay, answer B is correct. 10 to 15 years. This is the typical service life of well-maintained transmission line insulators. Now the next question is, which type of insulation is used in high voltage transmission lines running through densely populated areas? Okay, options are underground cables, overhead cables with polymer insulators, overhead lines with porcelain insulators, and option D is air insulated system.
Underground cables, madam.
A underground cables.
Yeah, option A is correct answer. Underground cable is used for highly populated areas. Okay. Now the next question is, what is the effect of broken insulator on transmission system? Options are, it improves system efficiency, it leads to a potential short circuit or power outage, it increases the overall system voltage, and option D is, it reduces the line losses.
Answer B, madam. Potential short circuit power outage.
Yes, and the main effect of a broken insulator is it leads to a potential short circuit or power outages. Okay. The next question is, which type of insulator is most commonly used in outdoor substations? Options are porcelain, polymer, glass, composite.
Substations, glass insulators, madam.
D, ma'am.
Hmm?
D.
Composite or insulators? D or B? So option A is correct. Porcelain insulators are most commonly used that in outdoor substations. Okay. Option A is correct. Now the next question is, what is the typical flashover voltage for high voltage insulator? Options are 1 kilovolt, 10 kilovolt, 100 kilovolt, 1 megavolt. Hmm?
Hundred kV, madam.
100 kV. Anyone else? So answer is 10 kilovolt. That is the flashover voltage for high voltage insulators. Okay. Answer B is correct. Now the next question is, what is the primary reason for choosing polymer composite insulators in coastal regions? Options are, they are cheaper than porcelain insulators, they are more resistant to salt contamination and corrosion, they are easier to install, and they have a high dielectric strength.
Answer is B, madam. Resistant to salt contamination, corrosion. They are
Yes.
used in sea areas.
Yeah, option B is correct. They are more resistant to salt contamination and corrosion. Okay. Next question is, which is a common issue caused by polluted insulators if not cleaned regularly? Okay, options are higher mechanical strength. Option B is increased leakage currents and flashover risk. Option C is enhanced dielectric strengths. D is reduced corona discharge.
Answer B, madam. Leakage currents and flashover risk.
Option? Which option?
B. B, madam. Leakage currents and flashover risk.
Yeah, this is right answer. Option B is correct. Now the last question is, how does a hydrophobic coating on an insulator help improve its performance? Options
Yes,
are,
answer
hmm?
B, madam.
B.
Prevents water accumulation, reducing leakage currents.
Yeah, option B is correct. It prevents the water accumulation and reducing leakage currents. Okay, okay. Here are some more questions. Um, low. Okay, what is the typical frequency of cleaning insulators in heavily polluted areas? Options are every 1 to 2 months, every 6 to 12 months, every 2 to 3 years, every 5 years.
6 to 12 months, madam.
Yeah, this is the typical frequency range. For every 6 to 12 months, insulators cleaning will be done in heavily polluted areas. Okay, now which of the following materials is commonly used for anti-pollution coatings of insulators? Options are silicon rubber, RTV, Teflon, copper.
Silicon rubber, madam.
Okay. Anyone else?
TV silicon. TV silicon.
RTV silicon?
A or B, madam.
Okay, option B is
B,
correct.
madam.
Okay, RTV, room temperature vulcanizing silicon coating is done for insulators. Okay. Next question is what is the primary disadvantage of using RTV silicon coatings on insulators?
Think B, madam. Degradation over time due to UV exposure. The temperature increases, the coating is also exposed to the
Yes,
temperature.
it's a correct answer. Option B is correct. That is degradation over time due to UV exposure. Okay. Now, which of the following methods is used for cleaning transmission line insulators in polluted areas? Polluted areas. Which cleaning methods are used?
Water spraying with detergent. It's looking like information. B, madam. Answer B.
Yeah, answer B is correct. Now, two more question is here. Like, what is the main reason of using deionized water for cleaning insulators?
It, it prevents formation of contaminants on the surface. B, madam.
It prevents formation of contaminants on the surface.
Yes, madam.
Okay, option B is correct. And the last question is what is the common method for cleaning heavily contaminated insulators in a transmission line?
Answer B or D.
Ma'am.
High pressure water jet with chemical based cleaner.
B.
B or D.
Okay, so the correct answer is B, that is washing with a high pressure water jet. Okay, so these
Okay.
are the some questions for exam purpose. This type of questions and some numerical problems will can also come. So all the
Madam,
best. Yes,
can you share this video with us, madam?
yes, I will upload it soon. Okay, you can go through
Ma'am,
it.
where can I find numerical problems?
Numerical problem are based on string efficiency and number of disks will be asked like this. You can solve it easily. Okay.
Is there video will be uploaded for problem numerical problems?
No, this is the last session for. Actually, this is the theory subject basically. So numerical is
Okay.
only based on suspension type insulators in which you will be asked for string efficiency or the table which I have showed, like what will be the right of way in meters for voltage ratings, or what would be the capacity like this. Okay. What would be the
Okay.
nominal system voltage for maximum operating voltage 145? This type of question will come, I think. And okay, this video will upload today, uh, and previous videos are also uploaded. You can go through it. And all the best for exam.
Thank you.
Thank you
Thank you very
for
much.
joining. Uh,
Thank you.
all the best. Thank you so much.